Yeah. So, hello student, good evening. So this is our electromechanical design concept that we dealings with the how mechanical system and electrical systems are correlated to make it interchangeable phenomena. So from the beginning, you know that as electromechanical system, the mechanical process is very natural and it mechanical energy conserved to electrical energy is the key process of our electromechanical system understanding. So electromechanical system, to know it properly, you need to learn first the mechanical and electrical system core principle. That means the mechanical system core principle is the law of gravity, that the force action between two mass and their distance of action. So that force is proportional to the mass of two massive things, and it is inversely proportional to the distance of their separation. So it definitely that without any charge action here, mass action is predominant. But in case of Coulomb's law, whenever two charges interact each other, then their action of force, either it is repulsion or attraction, depends on the charge. If it is the same charge, then it is repel. If it is the opposite charge, then it must attract. Here also the electrical force is proportional to the product of two charges. If two charges is Q1 and Q2, so Fe should be proportional to Q1, Q2, and at the same time it will be inversely proportional to the distance of separation. So Fe is inversely proportional to 1 by R square, and this proportionality constant K value, you know that it is 1 by 4 pi epsilon. Epsilon naught is uh, determined whenever the space is free. Whenever there is a permittive space or any medium, there is some relative permittivity, then it is no more epsilon naught, it is epsilon r and epsilon naught. So that is the relation between the mechanical system action of force between two massive body, and electrical system action of force between two charges. So here one thing we learned, that the mass in mechanical system is analogous to the charge in electrical system. So how we can relate it? So you know that the mass in mechanical system is actually follows the Newton's classical mechanics, the Newton's second law of motion, that F is ma. So m is mass, a is acceleration. So whenever there is a mass, you are applying a force, then there must have to work done. So the work done in different phase, we can say it differently. Say the certain force action with certain axial or lever distance, that is in mechanical system or applied mechanics, we called it as moment. And at the same time, the moment it transfer it in the rotational force, then it is torque. So moment and torque and work is almost the same thing. That is the Newton's second law of motion perspective. They are very similar or analogous. So I think the torque, we know that the rotational action, why the torque, moment and the electrical mechanical system we need to interrelate, because the torque actually very significant in electrical load system. So whenever there is a mechanical system, then we consider torque or moment, that is action of force and the distance wherever the lever acts. So in Newton's second law of mechanics, we know that F equal to ma, and in case of rotational force, the torque tau is I alpha. That means force is proportional to acceleration. That proportionality constant is mass. Whenever mass is greater, definitely for particular force, acceleration must be lower. In case of rotational system, the torque is proportional to angular acceleration. That means whenever any certain things that mass is greater, that how to say, the moment of inertia must be higher, and in that case, for particular application of rotational force, the angular acceleration must be lower. So think that how they are analogous. Tau is I alpha and F is ma. So here alpha angular acceleration is linear acceleration, tau is the angular or rotational force, F is the linear force. So in that sense, the moment of inertia is very significant factor in rotational load in electrical system. So you can see the different electrical load here. Here is motor, AC motor, DC motor, and rotor, and different segment of rotor. So you know that motor action is transformation of electrical energy to mechanical energy, and the alternator action or function is transformation of mechanical energy into electrical energy. So this transformation process, you need to know the core thing: the rotational action, the torque, tangential force, tension, the linear acceleration, the rotational acceleration, and the acceleration due to gravity. Such, because all the applied mechanics static part, we deals that the free body diagram, it nothing but absolutely the action, that free body diagram is the any massive body to make it neutralize against gravity. So that perspective, you need to know that how the weight or gravity is balanced by tension, how tension balanced by the rotational force, and how rotational force action at the center of mass, or it is actually driven by moment of inertia. So these are some mathematical derivation. We are not going details about it. We already discussed it in some last 1.5 years, hours about that. So now we are moving towards the concept of tangential moment, tangential force and rotational force, and tangential acceleration and rotational acceleration that we discussed before. So to deal with the electrical and mechanical system, you need to know another interface, that is friction. So friction concept is actually involved with again the Newton classical mechanics, that is mass action. Whenever any system mass is greater, definitely the friction must be higher, and that friction that counterbalance the normal force with the force due to gravity, and then the linear push force should be balanced by the frictional force. So in that case, we can make it in such a model that if normal force n is vertical upward, the weight due to gravity should be vertical downward, and if push force is horizontal forward, then the frictional force or retarding force should be linear backward. So such way it make it free body diagram. That means force vertical Fy should be balanced, and algebraic sum should be 0, and Fx horizontal direction resultant force must be balanced and 0. So in that ideology, we can derive the relation, we can find the frictional aspect of any frictional system. Then there is another two aspect. One is that the force, push force itself has certain angle. It will make more normal force, or it will make more uh, frictional effect. And another is the push force due to the slope action. It has incurred much more gravity action or more frictional effect. So such two consideration we can analyze through this frictional case. And whatever we discussed, that the friction, the moment of inertia, then rotational kinetics, that all dealings as a conservation of mechanical energy. And conservation of mechanical energy is nothing but there is a, if there is a certain massive system, it must have certain kinetic energy due to its movement. Then due to, if it attains certain potential level, then definitely it has certain potential energy, and if it has rotational action that we discussed before as a rotational torque, there must have a kinetic rotational action. So kinetic transitional, kinetic rotational, and the potential energy all will be as a energy system due to the circular system. So in that case we can consider that pure rotation, pure transition, and rotation plus transition, that will be more effective for design a circular thing to transfer the energy. So the practical example of transfer of mechanical energy to electrical energy is the hydropower. It is the way that how water flow or mass flow through a certain cross section as a volume flow. It rotates the turbine as a mechanical energy, then eventually it coupled with the generator and then transfer into electrical energy. So this is the process that how the mechanical energy or mechanical system or applied mechanic knowledge is important to design such prototype or hydropower systems. Here the key concept is mass flow, how related to volume flow, how volume flow related to cross section, and the normalized velocity of the mass of water. So in that case we can consider the mass flow and volume flow relation. And we also know that previously that the kinetic energy, potential energy, and energy due to gravity will be the effective energy to transfer as mechanical to electrical energy. In case of electricity, if you make it analogous that water flow through certain cross section of tube or pipe, it is similar as electric current flow through certain wire. So that the charge flow or charge analogous to mass of mechanical system we discussed at the beginning of our lecture. So here you can make it also analogous that electric current and water flow or charge flow similar as mass flow, and its cross section as electric charge density through a cross section or volume through a volume flow. These are very similar and analogous to water flow through the hydropower system. That's why this ideology, this concept is very significant to energy transfer process, because ultimately we are transferring mechanical energy to electrical energy. So the concept of electrical energy is actually involved with the electric field, charge, and electric current. And mechanical system also volume flow, cross section of the water flow, its velocity, and also the mass flow. So think that these are all analogous. So in case of mass flow, we should consider its density, water density is definitely very high. Then the velocity will be controlled by the potential or the height of the water level, and definitely it will get certain mechanical energy flow rate, that is actually ultimately transferred to electrical energy. So electrical charge flow, if we consider current, it is actually flow rate of charge, and then the current we can consider J into del. J is the current density, del is the area of cross section, and then in volume distribution we can relate this. Then another thing is the hydropower windmill. If you consider the water air turbine, then also the same concept that air flow, actually the natural flow, similar as water flow due to the dam or potential energy transfer into kinetic energy and ultimately transfer to electrical energy. Here the wind flow actually transfer the wind energy through the mechanical coupling of the wind turbine, and this power, wind power, we can consider through this design perspective that there is a mass, there is a density of air. Definitely the density of air is very less compared to water. That's why the windmill, the blade is very lighter compared to the turbine of water dams or the hydropower system. And here velocity of air also very less compared to the water due to gravity action. So definitely the energy density or power here in case of wind is differently less compared to water, mass flow or volume flow. So in that case the blade, lighter blade and the very bulk lengthy blade You know the torque concept or rotational concept or the moment of inertia concept. If the radius of any rotating system is very bulky, definitely the moment should be higher. Radius, the moment of inertia should be higher. It will encourage more mechanical energy to transfer ultimately into electrical energy. So such design perspective we should consider as a whole to think about applied mechanics and